Hey, how's it going everyone? It's Active Learning here. Welcome back to another video. In today's video, we're going to talk about TF-IDF, which stands for Term Frequency Inverse Document Frequency. This is going to be part 2 of our Words to Vector series in our NLP series. So let's jump straight into the video. So TF-IDF stands for Term Frequency Inverse Document Frequency, like we said. So let's understand it through an example, because that's the best way to understand something. Let's say we have these three documents after we apply stop words. In this example, the word good is present in all three documents, but words like dog and cat are only present in two of them, right? This means that we should probably give more weight to the words like dog and cat because they could signify something else, right? They could have different meaning that are more significant since they're more rare, right? And so the main idea behind TF-IDF is to give higher weightage to these rare terms within each document, right? Within all of these documents, like give higher weighting to all of these terms. So how do we actually capture rare terms? Well, we can determine their term frequency and inverse document frequency. So let's go over what each of them are respectively. So term frequency is basically the number of repetition of a word in a sentence divided by the number of words in the sentence. So we're going to go over some examples to actually apply this formula. And same thing for inverse document frequency, right? This formula looks pretty complex, but it's actually really simple to implement, right? So what this is that it's log base of E. E is Euler's number, right? It's around 2.7. And N here, it's the number of sentences. So for this case, it will be 3. And the number of sentences containing the word, for example, if our word is dog, it will be 2, right? It's pretty easy to understand, right? So it would be 3 divided by 2. Now let's go over some examples for term frequency, right? So let's go over how we can actually apply this formula, right? So I created a table here, right? A 4x4 table. And then I have the words good, dog, cat from our documents. And I have document 1, document 2, and document 3. So how do we apply this formula? Well, for good in document 1, we can just say the number of repetition of the word good in document 1. And the word good only appeared once. So it's 1 divided by 2 because there are 2 words, number of words in the document. So there are 2 words. So it's 1 divided by 2. What about for document 2? Well, it also occurred once out of 2 words. So it's also 1 divided by 2. And what about document 3? Well, good appeared once, but now there are 3 words. So now it's 1 divided by 3. Okay, so this is pretty intuitive, right? Really easy to understand. The word frequency is basically how often something appears. So if this word appears this many times out of those many words in a sentence, right, we can just divide it. It's pretty intuitive, right? And for example, in document 2, dog is 0 because it's 0 divided by 2, right? It appears 0 times, that's why. And so on, right? You can do some calculations yourself here. Okay. So now what about inverse document frequency, right? We saw the formula for this, but we haven't actually applied it. All right, so I created another table here, right? So we have the words good, dog, and cat, right? So the inverse document frequency is basically plugging in the formula. So the word good appear 3 times in total out of this corpus, right? Or all 3 documents, right? So it'll be 3 divided by 3. What about the word dog, right? There are 3 sentences and it appeared twice, right? Dog, dog. So it'll be log E 1.5, right? So that's around 0.4. And what about cat? Well, it's the same thing, right? It appeared twice and there's still 3 sentences. So it will be 0.4 for the inverse document frequency. So why does this matter? Well, we can actually multiply them together, right? Term term frequency times inverse document frequency, right? So how do we do that? Well, let's see. We can make another table here. We're making a lot of tables today. All right, so we have good in document 1, right? So good in document 1 is 1/2, right? Because it appeared once out of 2 words. And we're multiplying it by 0, right? That's the inverse document frequency of the word good. So then we get 0. What about dog? Well, it's 1/2 in document 1 as well. And we're multiplying it by 0.4, which is the IDF of dog, right? Okay, what about cat? Well, same thing. It's essentially the same for all of them. But what is important is that we might notice a pattern here, right? So we see that the word good is always 0 here, right? Why is it 0? Well, this is the essential idea behind TF-IDF, right? We're giving more weights to terms that are rare. For example, dog and cat. They only appeared twice in each document, while the word good appeared in all of them, right? So we can assume that the word dog and cat have higher meaning, right? So that's why we're them um, giving them more weights, right? Okay, so let's analyze them more closely now. So, for example, we have the word dog here, right? And in document 1, dog has a weight of 0.2. The word good has a weight of 0, and the word cat has a weight of 0 because cat doesn't appear in this sentence. And we also declare that good doesn't actually have much weight, right? Because it appears in all 3 documents. So then we're giving dog a weight of 0.2. Now, what about document 2? Well, we notice that in document 2, the word good is still 0 because, it appeared in all 3 sentences. And dog is 0 in this case because it never appeared once in document 2. And the word cat now is 0.2 because it appeared here, and we know that it has higher meaning than the word good. So we're giving it 0.2. That's from multiplying the TF by the IDF, right? That's what we get. Okay, what about document 3? Well, we notice that this term is smaller now because it has to share with the word cat, right? Because we have dog and cat in this case. The word good still has 0 weight here, right? But now we're sharing it between dog and cat. And yeah, that's essentially the main idea behind TF-IDF. It's not very hard to implement as well. So some of the advantages is that I guess you could say it's pretty intuitive, but another disadvantage I would say is that it's pretty complex, and what else? I guess sparsity is still an issue, right? You can have a lot of zeros in this case, right? And you can also get out of vocabulary, right? That's another issue you can get. So yeah, that's it for TF-IDF. It's really simple to implement in code as well. I might show that another time, but in this video, that's all we're going to talk about. So yeah, thank you guys for watching. If you enjoyed this video, please hit the like button. And if you have any questions, please ask them in the comment below. I would love to help you out, right? So yeah, see you guys next time. Bye.